We'll be going to this point. So this is repeat. So repeat these statements until this condition is true. Until this condition is true. So now while control statement. While control statement. So it is a little minor variation of this repeat until. In the case of repeat until, the condition checking is at the end. Condition checking is at the end. Proposition. Whereas here, condition checking is at the beginning. That's the only difference. So that means this may not be executed at all also. This may not be executed. This may not be executed at all. 0 or more times. This may be executed 0 or more times. All these statements may be executed 0 or more times. May be executed 0 or more times. 0 or more times. So while this condition is true. So that means condition is verified. If the condition is true, these statements are executed, and again we will go back to this condition checking. We will go back to this conditional checking. We will go back to this conditional checking. Go back to this conditional checking. So next is which is sometimes called as unconditional statement. Unconditional statement. But here also there will be some condition, but from the algorithm perspective, we are considering a different version. So that means whenever you want to do something, some fixed number of times, not based on the condition. If you check here, in while and repeat until, there is what is called as proposition. There is what is called as proposition. So here, in the case of for loop, there is no such proposition or condition checking. So for index variable, some variable, it can be ABCD, whatever you use, is assigned the values. First, it is assigned the value, initial value, and finally it takes what is called as final value. Finally, it takes what is called as final value. So initial value, then final value up to final value. But every time you will be incrementing it by incr. You will be incrementing it by incr. Means some variable takes the initial value. Okay. After taking the initial value, the statements are executed. So initial value, after taking the initial value, the statements. So it takes the initial value. After that, these statements are executed. After these statements are executed, so we go here. That means the value of this index variable is incremented. Again, here incremented means it can, this incr can be positive or negative. So can go forward or can go backward also. For convenience, let us assume that it is only incrementing. So initial value, execute these statements. After that, increment this variable. If it reaches the final value, then you have to stop. Otherwise what happens? So after this, after this, we are going to check whether we have reached this final value or not. If we have reached the final value, then this will be executed and will be coming out. If we have not reached the final value, then this process is repeated. So final value means there are two choices here. After checking whether we have reached the final value or not. So after reaching the final value also, you will be executing actually. After reaching the final value, you'll be executing. But when you reach the value, after that again you will be incrementing. But when you reach what is called as final value plus 1, when you reach what is called as final value plus 1 or anything more than this final value, so after that you will be going out. So what is happening? This index variable takes the initial value, execute these statements. After that increment. After incrementing, check whether we have reached the final value or we have exceeded the final value or not. If we have not exceeded the final value, then again execute these statements, again increment, again check, like this. This process is going to repeat. Until this index variable takes value which is greater than this final value. If increment is 1, then it will take final plus 1. When it takes final plus 1, these statements are not executed. It will go here. Okay. So that's how this for works. Just try to recollect. Or maybe you can note down. Takes the initial value, index variable takes the initial value. After that, statements are executed. After that, incremented. After that, which we are going to check whether we have reached the final value or not. So this algorithm works. One trick here, we will do it later. While doing programming, we will experiment. So we can enjoy that programming. Programming is a joy. It is something like mathematics. If you enjoy it, fine, fantastic. It will be easy for you. But if you feel it difficult, don't enjoy it, it will be really difficult for you. Okay, we'll consider an algorithm. First algorithm to find the maximum of two numbers. Okay, say first number is number 1, second number is number 2. So you can use anything. You can use A and B, number 1, number 2, N1, N2. It's your choice. There is no restriction. So always use appropriate names. That's all. So number 1 and number 2 are the two numbers. So what is the maximum? If I just show these fingers, which one is maximum? This one is maximum. This one is bigger. How you are able to tell? By comparison, by checking some condition, by verifying some condition. So you require these two numbers. So read the two numbers. Look at my hand. Don't just look at the screen. So this is number 1, this is number 2. So you need these two values. What is the value of number 1? What is the value of number 2? So because it can take anything. They are not just my fingers. So they can take anything. So read this. And then compare. Because you have to find the maximum, means we have to find which one is greater. Because we have only two numbers, the greater will be the maximum. So compare. If you consider the fingers, this one is shorter, this one is bigger. So you can say if it is A, if it is B, then B is bigger. If it is number 1, if it is number 2, then number 2 is bigger. Okay. So if number 1 is greater than number 2, number 1 is greater than number 2, then number 1 is bigger, so you print it, okay. If number 2 is greater, that means if number 1 is greater than number 2 is false, number 1 greater than number 2 is false, then number 2 is bigger, so you print the value of number 2. So that is the algorithm here. That is the algorithm. So read number 1, number 2. After reading, if number 1 greater than number 2, print number 1, else print number 2. Start and stop. You can see here, start and stop. These are the symbols that are used for to indicate the beginning of the algorithm and end of the algorithm. Say if A and B are 5 and 10, say 5 and 10. So number 1 is 5, number 2 is 10. If number 1 is greater than number 2, number 1 is 5, number 2 is greater than, number 2 is 10. Is 5 greater than 10? No. That means you cannot execute this one. So what is executed? Print number 2. What is number 2? 10. So 10 is printed. 10 is 5, then 10. 5 and 10. 5 and 10. So then what is printed? This one is printed. Now suppose this is 20. Okay, this is 10. This is 10. So number 1 is 20, number 2 is 10. If number 1 greater than number 2, 20 greater than 10, is it true? Yes. In that case, print number 1. What is number 1? It is 20. It is 20. So 20 is printed. 20 is printed. This is how the program works. This is how this algorithm works. This is how the logic works. Just have a look at it again. Just wait. Don't be in a hurry to complete the video. Pause it. So for this algorithm section and also for programming section, please try to pause the video as often as required. Don't be in a hurry. The first algorithm, first programs which you are going to write on your own is important. So first write 10-20 algorithms on your own. Understand them. Understand the explained algorithms and write some other algorithms on your own. So try to have successful experiences. Please remember, for any skill, successful experiences help you a lot. Successful experiences are required, not just for problem solving. We are solving here. Even for communication skills, learn communication skills. What is more important is successful experiences. So as an engineering student, probably you don't learn again these alphabets, pronunciation, phonetics, etc., grammar, etc. They are all maybe little relevant at this point of time. All what you have studied are there in your mind. The only thing is you should get the opportunity to bring it out. So they will come out automatically. When you have few successful experiences. So that's why you try to have few simple successful experiences. Talk to your friend. Talk to yourself. Okay. Talk to your teacher. Maybe in simple sentences. Don't try to participate in group discussion and try to show your talent immediately. you are not confident. So try to talk to your friend. Try to talk to your friend. Okay. Try to talk to yourself. Watch, say the news, English news or Telugu news, and then translate. So you will be watching the Telugu news and will be translating at the same instant of time. And when you are translating, please try to speak it out. Say it loud. Don't try to say it to yourself. Speak it out. By that way, you will get the confidence. So it is the confidence that is required. It is the confidence that is required. You are already a perfect human being. According to Swami Vivekananda, you are already a perfect human being. I believe in Vivekananda. I hope you also believe. In fact, many great people said the same thing, but in a different fashion, maybe. So what is the next one? Algorithm to find the sum of first n numbers. Algorithm to find the sum of the first n numbers. What does it mean? Sum of the first n numbers. First n numbers. It actually means, so you have to sum the numbers from 1 to some n. N can be 5, n can be 10, can be anything. Okay, but you have to start from 1. So next number is 2, next number is 3, like that up to n. Up to n. That means so if n value is 5, what you are supposed to do? You are supposed to do 1 plus 2 plus 3 plus 4 plus 5. So you have to do it. You have to do 1 plus 2 plus 3 plus 4 plus 5. Sum of the first n numbers. Sum of the first n numbers. So n value here is 5. N value is 5. Value is 5. Value is 5. So you have to do it. So you have to sum the first of n numbers. Okay. But what is the value of n? Is it necessary to know it? So because it is n means generally, I am not asking you to do the sum of first 10 numbers. Suppose if it is the first sum of the first 10 numbers, then probably you can do it like this. C some variable, C some variable. In that case, you can write C equal to 1 plus 2 plus 3 plus dash 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 2, say 10. So you can just write it and then print the value of C if it is the sum of first 10 numbers. But what I am doing here, I am asking you to find the sum of first n numbers. Now n can be anything. So if it can be anything, if it can take any value, please read it. So that's why we are reading. We are reading the value of n. First statement is read n. Now, okay, I have to add the numbers. So I should store it somewhere. I should store it in some variable. So here what I am doing, I am storing it in C. I am storing it in C. Okay, I am storing it in C. So instead of calling it as C, I call it as sum. Call it as sum. So what should be the initial value? What should be the initial value of sum? So it's better you keep the initial value, because in programming you may result in some garbage. So we'll see the reasons also. But it's better you initialize it to 0. Even if you don't initialize, you can assume that it is 0. So for this, for loop is convenient. For I equal to 1 to n, increment by 1. That means I value initially takes 1, then it takes is incremented by 1 until I value becomes n. When I value becomes n, it will be executed, and after that it will come out. Okay. So if we consider this case, sum is initially 0, Sum is initially 0. Okay, sum value. The sum value is initially 0. Sum value is initially 0. I equal to 1. I equal to 1 and sum is incremented. So value that is present is 0. Incremented by I value, that is present I value is 1. So what is it? Plus 1 is plus 1. Next, increment I, that means I value becomes 2. Sum equal to sum plus I. So what is in the sum? 0 plus 1. You can add it or you can keep it like this for convenience. So 2 is added. 2 is added. So like that you will be adding 1 by 1. You will be adding 1 by 1, and after completing this task you will be printing. You will be printing the value of the sum. You will be printing the value of sum. Okay, algorithm to exchange two numbers. Algorithm to exchange two numbers. So it is a little tricky. So you require two numbers again. Say num1 and num2 are the two numbers. I already told you can use any names, A, B, number 1, number 2. So here we are using num1, num2. Let those numbers be num1 and num2. Num1 and num2. Okay, num1 and num2. So what you have to do? You have to read the numbers. So because you are trying to exchange the two numbers, we want to know what are the initial values, what are the values after exchanging. So that's why we are just printing them. We are just printing them. Okay, this statement will have the effect of only printing. Will not change this logic. Okay. So num1 is say 10. Num2 is 20. So you are printing. So what are printed? What are printed? 10, 20 are printed. 10 and 20 are printed. So comma is not printed actually. So num1, num2 works like, we'll assume that it works like this. So 10 and 20 are printed. So after that, what we are doing? So num1 contains 10, num2 contains 20. So what we are doing? Num1 is assigned num2. So now what is num1? Let it separate. So num1 equal to 10. Is 10 initially. num2 initially 20. So is initially 20. Okay, num1 equal to num2. That means you are assigning the value of num2. What is the value of num2? That is 20. 20 is assigned to num1. 20 is assigned to num1. So now what the num1 becomes? What num1 becomes? Num1 gets the value of num2. Num2 is 20. Num1 gets the value of num2, that is 20. So num1 becomes now 20. So it is 20. So it is 20. Now num2 gets the value of num1. What is the value of num1? What is the value of num1? At present, num1 is containing 20. At present, num1 is containing, after execution of this statement, num1 is containing 20. So num2 becomes num1. That is value that is present in this num1, that is 20. 20 is assigned to num2. So 20 is assigned to num2. And you print the value of num1 and num2. What is the value? What is the value? It is 20. It is 20. So num1 and num2 printed means 20 are printed. So what happened? We are trying to exchange two numbers. We have written like this. Maybe mathematically it is correct. But if you use computer, it will not work. Now what is happening? It seems there is no problem with the algorithm, but it will not work on computer. Why? Think. Take a guess. Think. Take a guess. Take a wild guess. Pick something. Even it is wrong, doesn't matter. Pick out. What is happening? So it depends on how computer works actually. You should know how computer works. Can I show it here? Can I show it? How to show it? Have any? But the thing is, so whenever you are using the variables like this, names like this, say this is num1, this is num2, this is num1 and num2. 1, num1, this is num2. What we are initially storing in them? Num1 is 10, num2 is 1 is 10, num2 is 20. So what we are doing, num1 is assigned num2. That means the value that is present here is assigned to num1. That means we are actually what we are doing. So we are what we are doing, we are actually replacing the value of that is present in num1 with the value that is present in num2, that is 20. And then we are saying num2 equal to num1. So num2 gets the value of num1. Num1 is 20. So this will be removed. So this is same, doesn't matter, but that will be removed actually, and then gets it. So this is how the computer works. Computer will not remember the previous value. So here logically you may be thinking that okay, because the value of num1 is was 10, you should actually logically సత్యంగా నిజం అయితే అది అది అబద్ధం చెప్పదైతే మీరేమనుకోవచ్చు? You may think that if num1 and num2 are really true, they are truthful, then num1 value is 10, num1 value is 10. So the num2 should get actually 10 instead of 20. But it will not happen like this. Computer cannot remember all those things. It doesn't differentiate between these morals, ethics, etc. Okay. So it just stores it. It has, unfortunately, it has that location, that cell, we call it as a memory cell. has only memory cell has only that capacity, and if something new comes, it will be replaced. It will be replaced. It will be replaced. Okay. Just relax. Hope you got it. Just relax. I will tell you an analogy. Suppose in one say bottle or one glass, say there is petrol, in another glass there is diesel. Petrol and diesel are there. So here you are given two glasses full of, one is full of petrol, the other one is full of diesel. One is full of petrol, the other one is full of diesel. Now how do you exchange? So if you try to pour the content of one into the other, it will overflow. It may mix up, but it will overflow, and then this will be full. But if you try to pour it into this empty one, this will be full, this will become empty. This will not work. This will not work. Now we want to exchange petrol and diesel. How to do it? How to do it? What to do? Both are full. How to do it? Just think how to do it. Definitely you take another glass. Let me just check the video is working or not. Okay, fantastic. Video is working. Very good. Okay. What do you do? So you take another glass. What you are going to do? Take another glass. Pour this diesel into that glass. Third glass. And this is empty now, second one. So what is the petrol is present in first glass? Pour the petrol into the second one. So now it got the petrol. Now what you are going to do? What is present in the third glass? It is the diesel. Pour the diesel into this one, first one. Now this got the diesel, this got the petrol. So these are exchanged. So what does it mean? What is the moral? Moral of the story? Use another temporary variable. Use another variable. Or use another name. Use another variable. Okay. That you have to do. That you have to do. Hope you got it.